Have you wanted to automate your network devices with Python, only to find out that you can't parse the CLI output into structured data without extreme effort? We'll take a look at a tool you can use to make the process much quicker, and how you can develop custom parsing templates for it in this episode of Show Version 6. First up, the tool that we're talking about is TextFSM. This is a tool developed by Google to be able to parse unstructured CLI output into structured data. Now, what do we mean by unstructured data? Well, I mean data like this and this. Typical CLI outputs from your devices. This data is not easily parsed and used in scripts, and our goal will be to pull out the information we are interested in so we can use it in other parts of our scripts and automation frameworks. The TextFSM library itself is only capable of parsing text. However, TextFSM is included as a default parsing engine with another library that is used for managing connections to network devices, and that other library is called netmiko. If you aren't using netmiko, I highly recommend using the library, as it greatly simplifies establishing and handling SSH, telnet, and serial connections, sending CLI commands, and parsing the resulting output. We can see an example of this here, where we have a short Python script here, establishing a connection to a network device and sending a command where we note that the use TextFSM flag is set to true, so it will parse the resulting information. Then, here, we see the output in a structured native Python data format, a list of dictionaries. Just for comparison, let's see what the original CLI output looks like here. So, we've now pulled out the relevant information for us from this unfriendly output, in a way that we can now easily reference the values in other parts of our script. Let's say that we want to extract the system alarm information. If we check our existing list of templates, we see that the show system alarms command doesn't have a template currently. If we attempt to use netmiko and TextFSM to extract that command's information, we see the result is just a string of text, unstructured data. So, the command we want to extract information from is show system alarms. Next up, let's take a look at the format of an example template so we can review the necessary pieces. In this example of the template for show VLANs, we have three distinct sections of the template. First, we have this set of rows here that define values. Then we have a start section and a VLAN section. You might be looking at this template and feeling pretty intimidated right now. I don't know about you, but I don't know regular expressions well enough to immediately understand what this template is saying. And that's okay. After we review this template format, I'll show you a tool we can use so you don't need to know how to speak in RegEx to build your own templates. First, at the top, these rows that start with the word value are defining our variables to extract from the CLI output. After the word value, we have the variable name. This will be the dictionary key that the extracted value will be stored in. Then, in the right, we have in parentheses the regular expression used to define the variable. The following two sections, start and VLAN, are what are called states in TextFSM. The states contain a set of regular expression rules. When the line of output that is being parsed matches the rule, The values defined are set, and any action defined at the end of the rule line is taken, which can include finishing this parsed item, moving to another state, or continuing. Different states are used to extract data that is on separate lines of output. The parsing engine will always begin in the start state. Generally, you may not have any need for more than just the start state. If a rule doesn't match the line being compared, the rule will be skipped and the values defined will not be recorded and the action will not take place. So now we know that we need two primary pieces of information: a regular expression that defines our data that we want to extract from our output, and a regular expression that defines the entire line of output, including the extracted data. Let's first grab a sample CLI output of the command that we want to extract data from: show system alarms on our Junos device. Next, we'll head over to a regular expression testing tool called RegExer at regexer.com. This tool is open source. You can download and run a local copy of the application yourself if you want, or simply use this hosted copy of the application to help support the creator through ad revenue. What this tool does is it allows you to test regular expressions and show you a live highlighting of what the regular expression matches. Pretty cool, right? One of the things that really helps with this is the cheat sheet on the left. This is what saves us from having to learn to speak regex. We can simply reference the cheat sheet, test what we think will match, and confirm it does in the output below. We even have an explanation of the regex at the very bottom. Let's grab our sample CLI output and paste it into the test text section at the bottom and get started. The first thing we want to do is enable multi-line processing, because this is how TextFSM processes the output, line by line, instead of treating the entire output as a single string. Next, we want to ensure that our rule is always reading from the beginning of the line of text. You might recall that each rule in the sample template had the caret symbol at the beginning. This is a flag indicating to begin the matching at the beginning of the line. Now, let's take a look at the structure of the data we want to extract. We see that the output is in roughly tabular format. The first information is a date in 4-digit year, 2-digit month, and 2-digit day format. There's then a space and the time in 2-digit hour, minute, second format. There's then another space and an identifier for the time zone. 2 more spaces and we have a word defining the class of the alarm. 2 more spaces and finally a string providing the description of the alarm. Let's remove the sample regular expression from the top, so we're only starting with the beginning of each line. Now, the first piece of information we want to match is the date. We should probably save the time in a separate value. The date is of the format of 4 digits, 2 digits, and 2 digits, all separated by hyphens. In our cheat sheet, we see that we can define any digit using the \d, and we can define an exact quantity of the preceding reference by placing the quantity in braces directly after the reference. For the year, we would then use \d and the number 4 in braces. And for the month and day, we would use \d with the number 2 in braces. And we can separate each of these by hyphens. Now, let's put parentheses around this date group, since this will be our date value in the template. Now, we need to define the regex for the text between this value and the next that we want to extract. In this case, it's a single space. However, we don't necessarily know that it will always be a single space in all output cases. So let's say it just needs to be at least 1 space. We see in the cheat sheet that we can define a white space using \s. And in the quantifiers section, we can assign the one or more quantifier for the preceding reference using the plus sign. So our result will be \s plus sign for defining the space between the date and time fields. Now we need to create a reference for the time field. This is relatively simple, given what we know about the date field now. The time field is 3 sets of 2 digits, each separated by a colon. Using the same method we did for the date field, we have the result of this. Great. Now, just like between the date and time fields, we have at least one space between the time and time zone fields. So we'll use the same \s plus sign to define that area as well. Now for the time zone field. The time zone abbreviations are not always 3 letters. However, they are always letters and always uppercase, with no white space between them. Additionally, we know that at least one space will separate the time zone field from the class field. Using this information, we'll define our time zone field as being one or more of any uppercase letter, with A to Z plus sign. And we'll put this in parentheses to more easily map to values in the template. Now, we have at least one space between the time zone and class fields, so we'll use the same \s plus sign for that area as well. The class field can be one of several different values. We could specify each value it may be explicitly, or simply define it as being a word, which means any letters, uppercase or lowercase, and no digits or white spaces, using \w plus sign. Just like the other white spaces between fields, we'll once again use \s plus sign to separate the class and description fields. Finally, for the description field, we actually have a sentence. Now, the sentence ends with the end of the line, so we can simply say that all remaining characters on the line are the description value that we wish to extract. The period references any character except a new line, and we'll want one or more of any character to represent the description. With that, we come up with period plus sign as our description definition. With this whole rule together, we see that only the lines of data we're interested in are being matched, and the entire line of data is being matched successfully. Let's now take this rule and format it as a TextFSM template. Let's use our show VLANs template as our guide for formatting our show system alarms template. We won't need more than one state here, since all the data for each alarm we're interested in is contained on a single row of output. So let's just delete the VLAN state, so we just have the start state. Since we'll only have a single rule, our action at the end of the rule should be to record the values, instead of going to another state. Next, let's create our list of values. We should have date, time, time zone, class, and description. Now, let's paste in our new custom regex rule. Since we surrounded each of our values in parentheses, we can easily see the definition between them and pick them out. First, we'll replace the date value. A variable in the rule is defined using the $sign, then the name of the variable in all caps within braces. The regular expression we surrounded in parentheses, which defined the variable's value, is then placed next to the value definition above. Let's repeat this process for the other variables. Great. Our template is now complete. Let's now save the template and move on to the next step of inserting it into the TextFSM index so it may be used successfully. First, we need to save the template into the templates directory. where the other templates reside. This is where the Python package ntc-templates installed for me. The location will likely be different for you. We'll use the same file name format as the others, using the vendor name first, then the command used. Next, we'll need to add the file to the index. So let's open the index file, which is located in the same directory. We see at the top of the index that there are some instructions on how to add new commands to the index. The main format here is that we have a comma-separated values, where the first is the file name of the template, the next is the host name of the device that the template should apply to, the next is the platform of the device the template is to be used for, and the last field is the command whose output the template should be used to parse. Regular expressions may be used in any column except the first one defining the file name. Let's scroll down to the Juniper Junos templates so we can properly insert our new template. Then we'll insert our new template into the index. The templates are ordered first by file name length, then alphabetically. Since it will be the same length as show system uptime, it'll come before that one, since alarms starts with the letter A. We will use the same command format, so you may use the shortened command format in your script if you wish, and it'll still match the template. And that's it. Now let's go test our script once more and see if the system alarms information is returned in a structured data format. And there we have it. We see that a list of dictionaries was returned, where the list contains 2 dictionaries, representing 2 different alarms. We see our license and rescue configuration alarms are both returned, along with the expected contents in each key of the dictionary. With this skill of creating your own parsing templates for TextFSM, you are no longer limited to the templates that others have already created, and are free to go and parse any text that you see fit. Everything from command outputs to entire configuration files. I appreciate you working through this lesson with me. I hope that this has been informative for you, and I would like to thank you for viewing.